so number one, to be a polynomial, you have to be adding together, or adding or subtracting, terms. You can't have any negative fractions, decimals in your exponents, because they're just whole number exponents. So A is yes, that is a polynomial. Your degree is just your highest exponent, which would be 5. On B, so we have 3x to the 5th. That alone is a polynomial. The bottom is a polynomial. But if you divide those, then it is no longer a polynomial, because you would end up with a fraction which equates to like a negative exponent on our x. So this one is not a polynomial because there's x in the denominator, or x is on the bottom of a fraction. We can't have that. C, that one is not a polynomial. It looks okay at first. We're just adding and subtracting different terms. But the reason it's not is right here, that 1/2 power. So no, because there is a fraction in your exponent. D, all right, first look at it, is it breaking any rules? Do I have a negative exponent or a fraction exponent or x in the bottom? No, so it is a polynomial. Your degree is your highest power of x. It's like saying how many variables are there? If there's no x's, then what's my degree? 0. The same thing as if I wrote 3x to the 0 power. Anything to the 0 is 1. So that is a polynomial. Your degree is just 0, since there are no variables. Let's look at number 3. So this was just practicing all of your asymptote rules. So if we look at this one, vertical asymptote is what makes the denominator 0. Its asymptotes are lines, so you have to give me the full equation. So x equals. What makes the bottom of this fraction equal 0? So x equals 2. To decide horizontal or oblique, we first divide our highest powers of x. X squared over x leaves me with an x. So that is not horizontal, that is oblique. If you set this up, so we have x squared. If you want, you could put a 0x in there plus 4, dividing by x minus 2. Is everyone with me? So we start out dividing. What is x squared divided by x? X. Then you multiply. You take x times your x minus 2. So if you do that, you get x squared minus 2x. What do we do now? We always subtract it off. So take a negative through. X squared cancel. This would be 2x plus 4. What is 2x divided by x? And that's all you need. So your oblique is y equals x plus 2. Is that one okay? You have to remember that long division there. On D, so vertical asymptote, what makes the bottom 0? If I set x cubed minus 1 equal to 0, get x cubed is 1, cube root, so x is 1. To decide horizontal or oblique, we divide our highest powers of x. If I take negative 4x to the 5th and divide that by x to the 3rd, so those highest powers, that gives me negative 4x squared. Is it a line if you have x squared? No. So that means this one doesn't have horizontal or oblique asymptotes. It's not a line when you divide those. go to question 6. So graphing these rational functions, that's what we spent the majority of last week doing. So first step was factor. And on the test, it would be broken down just like this. I would identify all the different steps that I want you to do. So x minus 3 times x minus 3. All right, second step, x and y intercepts. So, x-intercept, how do we find those? It's when your y is equal to 0, so when the whole thing is equal to 0. Which we've talked about is really just when the top of your fraction is 0. So you just get 3. So on our graph, we know we hit the x-axis at 3. Make sure everything I ask you to find, I expect you to plot. Y-intercept is where you cross the y-axis, so x is 0. If I plug in 0 for all my x's, I get 9 divided by 0. Can you do 9 divided by 0? No, so there is none. Third thing, asymptotes, vertical asymptote. X equals, what makes the bottom of this fraction 0? 0. Okay, horizontal or oblique. So we can go back to the beginning. If I divide, x squared divided by x squared is 1. If there's not a variable in it, that's horizontal. Y equals 1. So I plot those. Vertical at 0. Horizontal at 1. All right, so now we have to get our graph from here. So we've talked a lot about test points to help you out. So if you want to plug in over here, you can put -1. It does not matter if you put it into the original or the factored form. But you get 16 over 1, so 16. So that is obviously above my 1. So I know this section looks like that. I am going to be a little bit picky on the test. Some of you, your graphs are not great. I'm not asking for perfect, but it needs to be close. What's wrong if I draw something like this? Yeah, it's not getting closer to my asymptotes. In fact, it's doing the opposite. It's getting further away from them. So that's not correct. What's wrong if I draw this? Because I'm seeing that on some. What's wrong with that? Yeah, it's not a curve. This should be curved, right? It should be a function. If I just draw a line coming straight down, is that a function? No. So your graphs certainly don't have to be perfect, but you do need to make an effort. It should be curved, getting closer to these lines as time goes on. Okay, over here, this graph does something weird. When you look at this, 3 was an x-intercept. It actually had a multiplicity of 2. If something has a multiplicity of 2, what happens to your graph? It bounces. You could always put in some test points and see. If you put in 1, you get 9, so I know it's up here. I have to hit this. If I put in a 4, I get 1/4. I'm still getting a positive. This one is just weird. It comes down, it hits it, but because it bounces, it's getting closer to my asymptote from the bottom. So that one, you had to have a few extra test points to kind of figure that out. I probably would not try to put anything super tricky on the test, so probably a little more straightforward, but that's why this graph turned out a little bit weird. Is that one okay? So if I look at B, so first step, factor. How would I factor the top? Replace with 2x plus 1 for x minus 1. Second step, x-intercept. That's when y equals 0, so this whole thing is 0, or really just when the top is 0. And so you get 0 and -1/2. y-intercept, if you put in 0 for all of the x's, you get 0 over -1, which is 0. Asymptotes. Vertical. What makes the bottom 0? So x equals 1. Make sure you plot. Okay, horizontal or oblique. If we divide 2x squared divided by x, what happens? We still have an x. We have a 2x. So this tells me it is oblique. And so to find the full thing, we have to do our long division. So 2x squared divided by x. And then you multiply. 2x times x is 2x squared. 2x times -1 is -2x. What do we do now? Positive 2x squared minus 2x squared, that cancels. X plus 2x would be 3x. What is 3x divided by x? 3. So that's my oblique. Y equals 2x plus 3. To graph that, that's a line. Y-intercept of 3. Slope is 2, so up 2 over 1. So it looks like this. I do know the middle section has to hit these points. Did either one of them have an even multiplicity? No, so it's just going to hit them and go through and get it closer to my asymptotes. So it should look like this, roughly. This section we need to pick something to see. So if I put in a 2. You would get 10 over 1, so 10. So that's up here. So this section looks like that. Any questions there? Number 9. Finding the complex zeros. So this sounds different than question 8, but it's really not. Question 8 was different in that all of your zeros were real numbers. When I say complex, I'm opening up the possibility that it might be an imaginary number, but it's not going to change how you solve it. We just start with our p's, q's, and possible zeros. So, my p-value, that comes from the constant. What's everything that goes into 20?
1, 2, 4, 5, 6.
I don't care what order you put them in, but you do have to have the plus and minus on all of them. What are my q values? 1. It's a number in front of the x to the 4th. Then your possible zeros. That's your p divided by q. When I do that, since my q is just 1, I just get these p values. Okay. I'm not going to rewrite them right now. Now what do? Plug them in until you find something that makes it 0. What makes it equal 0? 2. All right, these problems, guys, a problem like this on your test is probably worth 12 points. So you want to make sure you know what you're doing. Because you have to tell me the p's, the q's, possible zeros, your synthetic. There are a lot of steps. So now I'm going to do my synthetic. What do I know my remainder should come out to be? 0. That doesn't mean you just magically put a 0 here and hope it works. That means if you don't get 0, you find where you went wrong, because nothing else would work if you mess up your synthetic. So 1 comes down. 1 times 2 is 2. That's -2. -4 plus 9 is 5. 5 times 2 is 10. 20 is 0. Do you guys all know how I got that? So at this point, remember, your power goes down each time. Was x to the 4th, so this is x cubed. You might have factored this by doing grouping at this point, if you caught it. If you didn't, you can just go back to your list of possible zeros and find another one that works. Anything that didn't work the first time still won't work. But if 2 worked once, it's possible it works again. So what else works? Did anyone do a second? 2 2 works again. So you bring down our new polynomial. 2, 0, 0, 5. So you get x squared plus 0x plus 5. All right. We are trying to get our zeros and our factored form. So the zeros, if I set that equal to 0, x squared equals negative 5. If you add a square root, you do plus and minus. What's the square root of negative 5? So my zeros. It was x to the 4th, so there should be 4 of them. Plus and minus I radical 5, that's 2 of them. What else did we have? Right, because it worked twice. Your factored form, you could write a couple different ways. So zeros are just the numbered. Your factored form is when you have your parentheses. So if I radical 5 is a 0, it would be x minus I radical 5, x plus I radical 5. 2 is a 0, so x minus 2. Since that had multiplicity of 2, it would be squared. If you wrote it as x squared plus 5 times x minus 2 squared, I would also accept that. That's just because you had the x squared plus 5 here and it factored and had imaginaries. So technically either one is correct. That's why I had both on my answer key. I'll take either. B. So for the key values, we look at our constant. What goes into that?
1, 2, 4, 8.
Q comes from the leading coefficient, so that would be, so possible, P over Q. So 1 over 1, 1 over 2, 2 over 1, 2 over 2 is 1 and I have it, 4 over 1 is 4, 4 divided by 2 is 2, I've got it, 8 over 1, 8 over 2 is 4, 6 over 1, 6 over 2 is 3. Oh, that's not 6, that's 16. So that would be 16. And 16 divided by 2 is 8. You've got that. Okay, so what worked?
Negative 1/2.
Okay, so then we do our synthetic. Two times negative 1/2 is negative 1, plus 1 is 0. So we get 2x squared plus 32. If I'm trying to find my zeros, can I find it from here? If you set that equal to 0. So x squared is negative 16. To get rid of a square, square root, plus and minus. We get plus and minus the square root of negative 16 is 4i. So our zeros, positive negative 4i and negative 1/2. Now, the factored form. There are a couple different things you could have. If 4i is a 0, that means you have x minus 4i. If negative 4i is a 0, that's x plus 4i. And negative 1/2 would be x plus 1/2. But if you multiply this out, you don't get the original polynomial. In the factored form, it's kind of like undoing the slip and slide. Instead of x plus 1/2, what would you write?
2x.
2x plus 1. You just slide that 2 back in front of the x. So if you have a fraction, think of it as finishing a slip and slide problem, just slide that denominator back in front as your coefficient. Is that one okay? So number 10 is different in that I gave you the first 0. And if you have the first 0, we always do synthetic division. Now, this can get ugly because you have i's. If you were really worried about the i's, if you really struggle with that, is there another way you could find the zeros on this polynomial? You could do p's and q's. Could you just ignore the fact that I told you 2i was a 0? Absolutely. You could go back to p's and q's and do it that way if you wanted. But I gave you that first 0, so if you're using it, we just start with our synthetic. So 1 comes down. 1 times 2i is 2i. When you add those, we can only combine like terms. Now you multiply. So you're taking 2i times negative 4 plus 2i. So 2i times negative 4 is negative 8i. 2i times 2i right, it becomes 4i squared, which is negative 4. So those cancel and we get negative 8i. Negative 8i times 2i is negative 16i squared, which is positive 16. Do you guys understand how I got that? This is uglier, except we know if 2i is a 0, what else has to be? Negative 2i. The conjugate also works. So you just bring down this answer, except for the 0, since it was our remainder. We're going to divide again. So 1 comes down. 1 times negative 2i is negative 2i. Those cancel and we get negative 4. Negative 4 times negative 2i is positive 8i. Cancel and I get 0. So we have x minus 4. The question was for the remaining zeros. Okay, I already told you that 2i was a 0, so you don't have to tell me that one again. So what are my zeros? 4.
If you were to do p's and q's, you'll come up with the same answer.
Yep, you'll come up with the 4 that works, and then you'll get something that you could set equal to 0 and solve to get your imaginary one. Okay. Let's look at, so this time I told you 3 minus 2i was 0. So I'm going to do synthetic with 3 minus 2i. This is going to be a little bit longer, but we should get a nice answer at the end because I've already told you it's a 0. So when I do my synthetic, I should get 0 for my remainder. So 1 comes down. 1 times 3 minus 2i is 3 minus 2i. When I add, negative 9 plus 3 is negative 6 minus 2i. So I have to take negative 6 minus 2i times 3 minus 2i. You have to FOIL this. So you get negative 18 plus 12i minus 6i plus 4i squared. 4i squared turns into what? Negative 4 plus negative 18 is negative 22. 12i minus 6i is 6i. It's going to get worse before it gets better. So when I add my like terms, 21 minus 22, that's negative 1 plus 6i. So I'm taking negative 1 plus 6i times 3 minus 2i. So we get negative 3 plus 2i plus 18i minus 12i squared. Negative 12i squared, 12 plus negative 3 would be 9. 2i plus 18i, when I add, we get 30 plus 20i. So we have 30 plus 20i times 3 minus 2i. If we FOIL, we get 90 minus 60i plus 60i minus 40i squared. 60i's cancel, negative 40i squared is positive 40 plus 90 is 130. and we get our 0. Okay, that's the hard part of the problem. Everything from here on out should get easier. Because if 3 minus 2i was a 0, what else has to be?
Negative.
You only change the sign on the I term, so it's 3 plus 2i. And we take this answer we just got. But this time, all the i's should disappear. So 1 comes down. 1 times 3 plus 2i is 3 plus 2i. 2i's cancel and we get negative 3. Distribute your negative 3, so we get negative 9 minus 6i. 6i's cancel and negative 10. Negative 10 times 3, negative 10 times 2i, and everything cancels. Is that one okay? So from here we have x squared minus 3x minus 10, which factors into
Negative 5 plus 2.
So the question was the remaining zeros. If I ask for the remaining, that means give me the rest of them. I already gave you 3 minus 2i, so I don't need it again. So my other zeros are
Plus 2.
those are all the questions you guys have asked about.
It's just the highest one.
You multiply it out, you have 1, 3, and 2. So altogether that's x to the 6. So degree is 6. We know, even degrees, they look like parabolas. But this one had a negative in front, so what's going to happen? Both ends are going down, so indicator's down, down. Zeros and multiplicities. What makes x plus 3 equal 0? What about x minus 1? Right, since it's cubed, multiplicity of 3. And x minus 4? Everyone knows how to do that? Okay, you're good?
Yeah.
Okay, bounce or through. How do we decide that?
If they're even.
Yeah. Even or odd multiplicities. So, negative 3 had a multiplicity of 1. 1 is odd, so that one is 3. 1 had a multiplicity of 3. 4 had a multiplicity of 2. How do we find a y-intercept? So I have negative 1 over 48 times 3 times negative 1 cubed times negative 4 squared. Just get 1.
You just plugged in here.
All right, so now we plot everything. So we know it's not a good thing in 2 days.
How do I forget?
Oh, but you said I can't learn this in
No,
the
I
span of 2
said,
days.
how did I forget all of this?
All right, so zeros. We hit the x-axis at negative 3, 1, and 4. We hit the y-axis at 1. Okay, so I know my graph has to start down here. And when I hit negative 3, does it bounce or go through? Through. So it's just going to keep going. We know it's a curve. Got to come back and hit the y-axis here. And I have to hit my 1 and bounce or go through? Through. And I have to come back and hit here. And at here, at 4, we need to bounce. Make sure at the end that your graph is curved. If it turned into a zigzag along the way, just curve it, fix it. But then double check, is that the end behavior I set? Yes. Did I only hit my x-axis at the points that I had marked? Yes. If you crossed anywhere else, you messed up. Okay, we marked all the points where we can touch. Same thing for our y-axis. All right, so that was our graphing polynomials. Is that one okay?
Yes.
Let's do a quadratic one. Let's say after that. So again, I'm going to give you all the questions, A, B, C, D, E. You just have to be able to answer each of them. How do you know if a parabola opens up or down? So this is positive, so it opens up. Okay, how do I find my vertex?
X equals opposite b divided by 2.
So that would be a -8 over 2 times 2. So I get -2. But the vertex is an ordered pair. That's just the x value. How do you find your y?
Plug in negative 2.
Plug in -2 to the equation. Did you guys get -11? So -2, -11 is my vertex. Axis of symmetry, it's a line, so you have to give me the equation, x equals, and it's just the x value of the vertex. So x equals -2. And that's helpful because we know the graph is the same on both sides of that point. It's just the vertical line that goes through the vertex. Y-intercept, how do we always find that? 0 in for your x's, and we get so I hit at -3. So if I want another point, I can say, well, that's 2 away from my axis of symmetry. So if I go to the other direction, I have a third point. So now we can draw our graph. Oops. But hopefully yours looks better. What's the domain of that parabola? Every time, domain is always -2 to infinity. My range is starting down here, my lowest point, which was the y value, -11, and going up, so -11 to infinity. I feel like we've reviewed most everything else. We talked about asymptotes, graph a polynomial. Do you guys know how to do number 4, deciding if something is a factor? Just checking, do your synthetic division, see if you get a remainder of 0. I feel like we've actually gone through everything else.
Okay. So,